In this lesson at 10.4, we're going to continue to look at circles. We're going to be looking at inscribed angles and then polygons. Inscribed angles are going to be angles that are inside of our circle, but they're different than our central angles that we recently had. So we just talked about central angles. And central angles is an angle that comes off of the center of the circle. Okay, so this one would be central. An inscribed angle is one that's going to go all the way across the circle. The vertex of that angle is going to be on the circle's edge, not in the center of the circle like a central angle. Then we have intercepted arcs. So we've already talked about an arc. It's a part of the outside of the circle. An intercepted arc is it's an arc that's created by two lines, two rays, segments, anything that's cutting across that circle to make one arc. So right here, this blue one, we have an intercepted arc. Okay, and that intercepted arc would be minor arc AC. So when we talk about an inscribed angle, we can find the measure of it. So we've done the measure of central angles. Measure of a central angle we can always just find, and we can find the arc, but is always the same as the central angle. So I'm going to write that one out. Just before, we've had central angle is equal to the arc angle, or the arc. When we do inscribed angle, we use this formula here. So the inscribed angle is equal to half the measure of the arc that it intercepts. Okay, so the arc that's across from it, so here we have angle D, and the intercepted arc is this arc all the way from A to B, this minor arc created. So the angle is half of the measure of that arc. So when we look at this first example, we're going to be able to find that. So when we look at the measure of angle T, so the measure of the angle is half the arc. So the measure of angle T would equal half the arc that it intercepts, the arc across from it, of RS. So we plug this in, half, RS is 48, it says on the outside there. So we put in our 48. And so half of 48 gives us 24 degrees. So the measure of angle T is going to be 24. We're going to do the same thing for the second one. So I'm going to erase this formula and redo it. So on my second one, I have the measure of angle R. Okay, that's my angle measure. So measure of angle R would equal half the arc it intercepts. So the arc the angle R intercepts will be this arc that's across from it of QT. So I plug this in. Measure of angle R we know is 50. And so I have 50 is half of QT. To get Q by itself, you could do it to get QT by itself, you could do it two different ways. Either divide by 1/2. If you want to use a decimal, you're more than welcome to. But I could also just get rid of the 2 in the denominator here by multiplying by 2. So when I do this, my 2's cancel. And so on the right side, I have 1 QT, so that's just QT by itself. And then I have 2 times 50 gives me 100. So the measure of QR, or measure of QT, in this case would be 100. And then we want to find what's left over. So if we look at QT here we said is 100, so I'm going to write that in. Hey, but they ask for QR. So QR is the one over here. I'm going to mark it just in red. Okay, so QR, if we notice, we have a line here going all the way across. So the degree measure of a line is always 180 degrees. So that means we can just subtract. So to get what's left over for QR, I would subtract 100 from 180, and it would leave me with 80 degrees. So that means QR has to be 80. So in example 2, now we're going to find the measure of arc RS and the measure of angle STR. So if we start with the first one, the measure of arc RS. RS is this one here. Okay, and so it is across from this angle. This is the intercepted angle for it, or the one that we have. So SR, okay, our formula says that we take half of the intercepted arc is equal to our angle. So half of SR would give us our angle of U. We know the measure of angle U is 31. So half of SR is equal to 31. So to get the actual measure, I'm going to multiply by 2 to both sides to get rid of my 2 in the denominator. So SR is equal to 62. So if I plug that in, I'm going to put my 62 out here for the arc measure. Then we also want to find the measure of STR. So STR is this angle. If we notice, the intercepted arc for it is the same arc of SR. So my measure of angle T would also equal half of SR. If I plug that in, half of 62 is the measure of angle T. So half of 62 is going to give me 31. So the measure of angle T is equal to 31. And so then this problem asks us to compare those two angles, STR and RUS, the two angles that we have here. And so if you notice, they are the same. Okay, this is going to clue us into this next theorem, inscribed angles theorem, because it's going to be, we have two inscribed angles that intercept the same arc. So obviously, if they intercept the same arc, they're going to follow that same exact formula. They're going to be half the size of the arc, and so that would make them both be congruent. Okay, no matter what that arc measure is, we're going to take it half both times, and it's going to be exactly the same. Okay, the next theorem we're looking at, or the next part of this lesson, is we're going to have inscribed polygons. So an inscribed polygon is just when all of the vertices of that polygon are going to lie on the circle. Okay, if you notice, every single corner of this polygon is on the circle. It's on the circled line. Okay, if it wasn't, then it would not be an inscribed polygon. And so then it also tells you that the circle that contains all those vertices is called the circumscribed circle. So then based on that, we have a few theorems that kind of narrows things down for us. Whenever we have inscribed right triangles always have the hypotenuse go across through the diameter. So if you notice, this one is going to be a right angle because the hypotenuse across from my right angle goes through, it's the diameter of the circle, it goes through the center of the circle. And then we have inscribed quadrilateral theorem, and it just tells us when we have a quadrilateral, the opposite angles are always going to be supplementary to each other. So here, angle D and angle F are going to add up to be 180. Angle E and angle G are going to add up to be 180 degrees. Okay, they're going to be supplementary when we sum them up. So using those, we're going to work on this next problem. This asks us to find the value of each variable. So in this first one, we have a triangle that is inscribed into the circle. And so it tells us, or it shows us that AB, this one side of it, goes through the center of the circle. And then we want to find the value of X. Well, since it goes through the center, that means this has to be a right triangle. So if it's a right triangle, the degree measure there, right triangle makes it 90 degrees. So that would mean 2X is equal to 90. And then to solve for X, we divide by 2. So X would be 45. In the second one, we have an inscribed quadrilateral, and so we just said the opposite angles in quadrilaterals add up to be 180. They're supplementary. So if I do the opposite ones here, angle D, the measure of angle D plus the measure of angle F, opposite ones, is equal to 180. So if I plug that in, Z plus the measure of angle F is 80, is equal to 180. Solve for Z, I'm going to subtract 80. And so Z is equal to 100. My other one going the other direction, I have Y and 120, so angle G and angle E. And I'm going to go and erase this other side so I have room. So the measure of angle G plus the measure of angle E would also equal 180. They're supplementary. So I plug that in. G is Y. E is 120. To get Y by itself, I subtract 120. And so Y is going to be equal to 60. And that problem will be done.